Hello, welcome to Lesson 1, Part 2. Today's learning target is I can find the area of a rectangle with fractional side lengths. So we're going to build on yesterday's lesson about finding the area of a rectangle by adding to that rectangle side lengths that include a fraction, such as 3½ Okay, so we'll start by reviewing yesterday's lesson. Here is a problem. We have a rectangle with two side lengths and is drawn on a grid. So what are two ways we could find the area of this rectangle? Well, if you think back to yesterday, you might remember that one way is to simply count the squares inside the rectangle. That'll give us the area. So let's do that. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares. So we can say that the area of this rectangle is equal to 12 square units. Do you remember a second way to find the area of a rectangle? You might recall from yesterday that we also learned we can find the area by multiplying the length times the width. So the length is 3 units long. The width is 4 units long. And so if we multiply them together, 3 times 4, we will get 12 square units. Don't forget the squared part in your label. It's super important to let your readers know you mean an area of something. All right, so those are the two ways that we learned yesterday to find the area of a rectangle. We can simply count the squares if that's available to you, or you can multiply side lengths, and that might be the more common method. So let's go ahead and just practice this one last time before we move on to some maybe more challenging material that involves fractional side lengths. Here is another rectangle. What I'd like you to do is to find the area of this rectangle and then explain or name which strategy you used. Okay, so in Edpuzzle, write the area of this rectangle and then write which strategy you used. I'll meet you on the other side of this problem. Work hard. Welcome back. Okay, let's see. Some of you might have used the counting strategy. So let's do that. If we counted up all these squares, wow, there's a lot of them. Let's do this pretty fast. Okay, you ready? Here we go. Keep up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. If you counted correctly, you would have come up with an area of 36. See, the area is equal to 36 units squared. Don't forget the squared. All right. Some of you might have used the multiplication strategy, the procedure. Area is going to be equal to the length, 9 units, times the width, 4 units. So we could have done 9 times 4 equals 36 units squared. Don't forget the squared. All right. Those are the two strategies we learned yesterday. Today's lesson is really going to focus on one of those two strategies, and then we'll pull in the second later on. Okay. So let's go ahead and take a look at our first rectangle with fractional side lengths. Okay. So there isn't a lot that's different here. We're still talking about rectangles. We still see squares inside the rectangles that we can count. We still see measurements of the dimensions of the rectangle. The only thing that's different is that one of the edges of the rectangle doesn't line up along the grid, does it? It's kind of halfway between the grid lines, giving us a fractional side length. So here is one strategy for finding the area of a rectangle with a fractional side length. Are you ready? We can count all the pieces. We'll count the whole square units, and we'll count the fractional square units, and then we'll add them all together. Does that sound good? Let me show you what I mean. All right, so if we just start with the whole square units, okay, we're going to have, let's see, 1, 2, 3, 4, 5, 6, 7, 8. We see we have 8 whole square units. So I'm going to write that. So far, the area of most of this rectangle is 8, but we do see that we have this piece here and this piece here. First question is, how much of the squares is that? And then we use that information to come up with an amount that we can add to the 8 and get a total area of the rectangle. And so where we want to look to find out how much of the rectangle that could be is here in the measurement of the length. So the length goes from this side of the rectangle to that side. And it says that that length is 4 1/2 units. So let's count up the 4 units first. Are you ready? Let's see here. There's 1 unit of length, and there's another, okay? And there's another, and there's another. It almost looks like a number line, doesn't it? Yeah. All right. But look, we have some left over. Look at how far this side length goes. Doesn't it seem to fall about halfway between one edge of the grid and the other edge of the grid, right? That's almost 1/2. In fact, it's not almost 1/2. It is exactly 1/2 of the length of a square. And that's how we know it is 4 1/2 units. All right. So it turns out that this is half a square right here. So we have 1/2 there. So we can add that to the 8, right? Whole units. And we have another half right here. So we have 2 half squares. So that's like adding up another half. So now we have, to find the total area of this rectangle, 8 whole square units plus a half a square unit plus a half a square unit. Do you remember from last year when you added fractions that have like numerators and like denominators? So let's say putting 1/2 and 1/2 together. Well, you might remember that 1/2 and 1/2, when you add them together, is actually equal to 1. And so what we end up with here is 8 plus 1 whole square unit for a total of 9 square units. And that is the area of this rectangle. Now, if that adding of 1/2 plus 1/2 equals 1 is a little bit confusing, let me draw you a picture, and maybe this will help to clarify. So if we draw half of a pizza, right? And we draw the other half of the pizza, and we could bring those together so they look like this, we'd have 1 whole pizza. 1/2 and 1/2 is 1 whole. Okay, are you ready for the next problem? You want to try it? Here we go. This time, what I'm going to do is have you work on your own in Edpuzzle, on your paper in front of you, however you're working. I want you to try to solve this problem. What is the area of this rectangle? You see it has a length of 7.5 units and a width of 2 units. And some of the boxes are already drawn in for you. I will meet you on the other side of this problem, and we'll work on it together to see how you did. Good luck. Work hard. Okay, welcome back. Let's talk about this problem. We see, just like yesterday, this is a rectangle with only some of the boxes filled in, right? Do you remember some of those problems from yesterday where only some of the boxes were filled in? Do you remember what we did first when that happened? That's right. We drew in the rest of the boxes. So let's do that. Let's draw in the rest of the boxes. Look at that. All right. So now we have all our boxes drawn in, and we can start with the same strategy, the same first step. Let's count the whole square units. Ready? Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so let's write down what we have so far, 14 whole square units. But we also have some fractional units, don't we? Over here, we have this fractional piece of a square unit. We have this fractional piece of a square unit. And we have this measurement. So we're told this is 7.5 units long. So this has got to be half a unit, right? So if we just count up units, we got 1 here and another 1 here and a 3rd unit of length there and a 4th unit there and a 5th and a 6th and a 7th. And then we have 1/2 of a unit, right? This distance is 1/2 of this distance. That's 1 whole. Okay, so this is a half, just like in the last problem. So we have 14 plus 1/2. And we have this half right here. Yeah, so we're going to add another half. And do you remember from the last problem what 1/2 plus 1/2 is? That's right, 1/2 plus 1/2 is 1. So let's add 14 plus 1 whole square unit. That's the total here. This adds up to 1 whole square unit. 1/2 and 1/2 makes 1 whole. And we'll get, as an answer, 15 square units. And don't forget the squared. It's really important when you're talking about area. Okay, let's try another one. I will meet you on the other side of this problem. Okay, I want you to try it on your own. Put in your best guessed answer into Edpuzzle, and then we'll work on it together. Good luck, work hard. Welcome back. Okay, we see another rectangle. It has a fractional side length, and it has some of the boxes in the middle filled in, but not all of them. Now, what was the first step we did in the last 2 problems? That's right. We started by filling in the rest of the boxes. So let's go ahead and do that. I will try to draw as neatly as I can. It's kind of hard when there's so little friction between the stylus and the screen. It's so smooth. It's easy to slip around like ice. Okay, there we go. So now the second step is to count the whole square units. Let's go ahead and do that together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. We have 12 whole square units. That's kind of the easy part now, isn't it? But we also now have fractional units, and these fractional units are different from the first 2 problems, right? These fractional units are thirds. This is 3 1/3 long. So this distance here, right? We have 1 whole unit of length here, another whole unit of length here, another whole unit of length there, and then this distance right here is just 1/3, which means this, it would take 3 of them. 1, 2, 3, right? In order to make 1 whole. So this is 1/3 of a square. So let's add that to our total number of whole units so far. Here's another third of a square. Let's add that up. Here's another third of a square. So that's 3/3. Oh, does 3/3 sound like anything? I said 3/3 and I wrote 3. There's another third. So 1, 2, 3. Those are 3 1/3. And we have a fourth one right here. So that's 4 1/3 pieces of a unit. So now we got to figure out what 1/3 plus 1/3 plus 1/3 plus 1/3 is. I think you might have learned something like this in 4th grade. Do you remember back to 4th grade and how you add up fractions that have the same denominator and the same numerator? That's right. That's right. Yes, you just add up the numerators. So we keep the thirds, and we just add up 1 plus 1 plus 1 plus 1. 1 plus 1 plus 1 plus 1. That's 4. 4/3. Well, 4/3 doesn't help me, though. Okay, what does 4/3 even mean? Can you have 4/3? Well, you can, but let's figure out what it means. Let's go ahead and let's take one of these pieces, and what if we just moved it over here, and we redrew it? There's our 1/3. And what if we took this piece, and what if we moved it right here next to it, and made another third? And what if we took this piece, and we moved it right next to it? Do you see what we have now? Does this square I just made look kind of like these whole square units over here? They should, because 3/3, right? 3/3 makes 1 whole. A third and a third and a third is 3/3. That's 1 whole. That's having 3 pieces out of 3 pieces. So we can call that 1, right? So we have now 12 plus 1 whole. That's good, right? And we have this 1/3 left over. This is the same. This third here is that third right there. It's left over. And since we can't add it to anything, we'll just write it at the end of our number. So we have 12 plus 1. That's 13. And this 1/3 will bring down 13 and 1/3 square units. Square units. I don't need the 2 because I wrote the SQ period. I identified square units. So that's how we tackled that problem. Did you get it right? That's okay if you didn't. Let's try one more. Okay, here it is. It's another rectangle that has thirds as a fractional part of the side length. Go ahead and I'll meet you on the other side of this problem. Work hard. Welcome back. Let's tackle this problem. All right. much like the first, let's fill in the rest of the boxes nice and neat, as neatly as we possibly can. Wow, that wasn't very neat. Let me go ahead and just, I'm okay with being a little messy, but I'd like to just try that one more time. That's a little better. All right. More importantly are the rows. Let's see if I can straighten those out a little bit. Okay. And then this last one stays really close. Okay. Good enough for the purposes of this math problem. Now, second step, let's count them up. Are you ready? Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 whole square units inside of this rectangle. And we also have, much like the last problem, thirds left over, right? This is 5 1/3. So this length here, from here to here, is 1/3 of a square. And so this is 1/3 of the whole square in area. That's 1. So we're going to add up 1/3. And we have another third here. So let's add up another third. Boy, this looks a lot like the last problem, doesn't it? In a way. We have another third here. So let's add up another third. And a fourth third right here. Let's add up another third. Now, we have a third plus a third plus a third plus a third. We just did this. We just learned that 3/3 makes a whole. I could draw you a picture. There's a whole pizza. And if I have thirds, you got 1, 2, and 3. I have all 3 pieces out of all 3 pieces. That's a whole pizza. So that's really what we're saying is we have 20 whole square units plus another 1 square unit plus this third left over, which we'll bring down and add. So we have 20 plus 1 plus a third. That's going to give us 21 1/3 square units. Don't forget your squared. It's really important. All right, so counting up and then adding the pieces together and then adding them all together into one sum is the strategy for how right now we are going to find the area of rectangles with fractional side lengths. Okay, I'll make a second video that won't be an ed puzzle that will demonstrate another way, another method. But for now, I want to stick with just this method, okay? And before we go, I do want to offer up one last problem for those who are interested, okay? I'll make another video about this. So if you want to work with me on this, check out the challenge video, okay? Because this is a super tricky one. All right, so thank you for watching and working so hard in this lesson. Please make sure you complete your assigned practice work. And if you want to learn more, you can check out the next video on a second strategy, or you can try this problem and work with me on it in a separate video. Okay? All right. Work hard and let me know if you have any questions.